Hi everyone. This is a simulation of how to create a sampling distribution, and we'll look at some properties of the sampling distribution based on our sample size and how changes in the sample size can affect the shape predominantly of the sampling distribution. Alright, so let's take a look at this data set here. Here we have a data set. It looks like the amount of change a person had in their pocket when they were surveyed for that information. So person 1 looks like they had 97 cents, person 2 had 99 cents, and so on and so forth. And if we scroll down, it looks like this population, the overall amount of data that we have here is 1,000 individuals and how much change that they had. So what we're going to do is build the sampling distribution by bootstrapping from this population here. Okay. So what I'm going to do first is notice we have the population data here, and we see that the shape of the population is roughly uniform. Could be classified as maybe multimodal because we have these distinct peaks in the data here, but roughly uniform. Kind of looks just like a rectangle here. All right, we also notice that the average of the population is about 50 cents. The standard deviation is about 29 cents. And we see the size of the population, which is 1,000. So what we're going to do first is take a look at just if we were to take random samples. So we're going to randomly take samples here of a small size. And what the software is going to do for us, it's going to put our current sample here, so we can take a look at that, and then it's going to collect the sample means over here, right? For each of the samples that I take, it's going to collect the sample mean and put that here. What we're going to do is just take a bunch of samples, and we're going to end up building the sampling distribution for the average amount of change, the sample average amount of change that these people had. We'll take a look at what that looks like. All right, so let's start with a small sample size. Let's change this to just 5, right? So I'm going to take one sample of size 5. So the computer just randomly generated these 5 individuals and their amounts of change. So you can see here that the sample data includes these 5 individuals. You can also see them where they were located in the population, which is pretty cool. Now you'll also notice that the average is calculated as 0.73, and that is generated over here. This little block right here represents that average. All right, let's do another sample. We'll draw another random sample of 5 people. And you see that we get a different sample, different 5 people. Their average is much lower this time. It's 0.474. And that little block is put on our sampling distribution over here. So what these little blocks are going to do, we're going to collect them as we do our samples, and going to build that sampling distribution for the sample mean amount of change. So let's draw a few more. You can see, if you keep your eye on those graphs down there, how the sampling distribution on the right, the bottom, is being generated. Right, so effectively the software is building a histogram of the sampling distribution for us as we draw samples of 5. Now, to kind of save a little time, let's draw 100 samples of size 5 from the population. Right? This is going to give us the very last one that we calculated, but you can see that the histogram filled in rather quickly. If we do another few samples of that size, we see that the histogram is being created here. So we have, looks like 1,022 maybe samples. And we notice something happening with our shape, right? So the shape appears to be roughly normal, right? We can see some deviation from that, right? This portion here is not quite as symmetric as, not quite symmetric to the portion on the left side. We can also see some left skew happening here that doesn't quite happen on the right, okay? We can also take note of the mean and standard deviation as well. So we notice that the mean is exactly equal to the mean of the population. That's interesting. But the standard deviation is much smaller, much smaller. So I'm going to take note of that. And we'll change our sample size. I'm going to save this so we can compare later on. Then we'll come back to it. So this is n equal to 5, right? All right. So what I'm going to do now is just change the sample size. So I'm going to change this to something larger, right? So we know if you've done your work for chapter 13 and 14, you should know that there are various conditions for the sample size so that we get a normal sampling distribution. Since we're dealing with means here, the magic number is 30. So let's change that to 30 and see if we get a little bit of a better shape. All right, so we will take one at a time again, just to start out. So now you see here I've got many more dots because we've changed the sample size. So now we're taking samples of size 30 and again building that sampling distribution over there on the right. So let's do the same amount. We need 1,021 more. So let's draw those. And there we have it. So we can notice something that's happening when we up the sample size to the magic number, which is 30. We see that compared to last time, we have a much more normal shape to our sampling distribution. It's much more symmetric than the last time. You notice that the mean is roughly the same, right? Here, as the population. And let's think about what happened to the samples, the standard deviation. Let's compare those. This is with n equal to 30. If we look at that comparison, you can see more normally shaped distribution. Of course, the means are about the same, but the standard deviation is much smaller here. So you can see how this was spread from about 0.1 to about 0.9, maybe 0.85. This is now 0.3 to 0.7, so lowered the standard deviation when we increased that sample size. Now let's see if we make it a little larger, it'll get even better. Or not. So let's change it to 75. And we'll take the same number of samples. And there we have it. So we see the same kind of thing happening. The mean is exactly the same as the population mean. The standard deviation got a bit smaller this time. And it looks like we improved that shape, the normal shape of the sampling distribution. Let's do it once more. And recall that there was another condition that said we should not sample more than 10% of the total population. So let's go over 10%. Let's say we sampled 150, right? Remember there's 1,000 individuals here, so 10% would be 100. So let's go over that. Let's say 175, let's say, and see what happens. Okay. So you can see here that we get roughly a normal shape, but you can see we're starting to kind of lack that symmetry around the center here. The mean is roughly the same, and the standard deviation got a little bit smaller than the last one. So you can see here, we can overlay the normal distribution. It fits it pretty well. We have some deviation here. All right, so that's what this gist of sampling distributions is all about.